4 years. 4 years is a long time. I've sacrificed so much. I live in a 10 by 10 room. I hardly go out. I don't really have friends here. Yeah, I've been through a lot, and what do I have to show for myself? This, a prototype that's not even fully working yet, and a book.
What's in the book?
Everything I know about railguns. There's a lot of interesting stuff in here, stuff that most people haven't seen before.
Can you show us now?
Well, no, it's a secret. I don't think the public will ever see this. I decided it was time for a new batch of PCBs, and this time I chose Oshpark since purple and gold really appeal to me. The build quality on these things is just amazing. They even did the isolation slot perfectly. The only complaints I have are the thorns left over from the panel and the fact that the solder mask is ever so slightly offset at the corners. This is the new cab charger board that is based on my old adversary, the LT3750, and the Coilcraft DA2034 transformer to go with it. Next is the Stm32 board that at its center houses the STM32F103C8T6 ARM Cortex M3 microcontroller and a USB-C port. I'll admit that I was a little hasty in designing this board and left out the boot jumpers. What's worse, for some reason the package for the STM32 was just a little bigger than it should have been, which renders this beautiful and costly board useless. The power board contains the usual fuse. This time it also comes with a P-channel MOSFET for powering additional accessories. The backside contains the gate drive transformer, which I will talk about later, and the necessary driver. These boards were designed to take full advantage of the golden Enig finish and 2-ounce copper. You can admire them here for a few seconds. It is an unfortunate fact that things don't last very long in the electronics industry, just like this freshly outdated cab charger. I got this surprise package one day that contained the free samples I ordered from Coilcraft a long while ago. Without hesitation, I opened them to find that it contained 3 pieces each of the LPH8045 triple winding inductor and the DA2034 transformer. The transformers are quite heavy and they feel solid, and of course, they are quite shiny. I decided to put something together quickly using these two parts that I'll borrow from one of the old trigger boards. Together with this inductor, they should make a decent isolated gate drive circuit. Though it doesn't look the best, it works quite well. Of course, all that stuff needs to go inside something, and it's not surprising that it took me this much paper craft to come up with this. I finally came up with an agreeable design when I was bored in school as usual. It's not surprising that I've spent 4 months cutting stiff card into shape. The body is going to be made of aluminium and I want to get it right the first time. The body consists of 4 major groups of parts. First, a pair of base plates, the outer body itself, the capacitor holder, and of course the two halves of the Nerf Firestrike handle. All this is held together using 8 5mm M3 bolts. First, the base plates fit onto the two posts in the handle halves. Then the handle halves are put together. The cap holder screws into the base plates using 4 screws. Of course, the aluminium won't be so floppy. Finally, the body is screwed on to the base plates. Okay, it's really awkward to do this on camera. Alright, I give up. I'd better do this off camera. The end results don't look too bad. I can't wait to see this in aluminium. I decided to try out one of my more crazier ideas to power the railgun. This is a high power buck converter, or at least it's supposed to be high power. This is only a small scale prototype. The final version that's supposed to go in the railgun will be 10 times smaller volumetrically and 10,000 times more powerful. I don't know about that, but at least this prototype steps down 12 volts to a nice and usable sub 1 volt and steps up the current too. My standard way of measuring if a component is hot is to soak a brush in water and gently place it on the component. If it's hot, you get a satisfying hiss. A few interesting things about this buck converter. The load is on the high side, the switch is a large IGBT, and the diode is replaced by a diode connected SCR. Of course, not all of this is implemented in the prototype. Somehow, this thing managed to kill 8 gate drivers because of the nasty supply spikes it generated. Maybe I should have just used these GDTs. To run this thing, I wrote a quick little Arduino sketch that acts like an interpreter where you can input the on time, off time, and the number of pulses and output them when you press enter. There used to be a time when I thought all dips 8 packages were 555 timers. I'd gladly give all this up.
The old times, huh?
Yeah, I'd give all this up and turn back the clock to say 4 5 years to simpler times. Everyone has to start somewhere, and I was no different. When I started this project, all I wanted was an electro laser to zap my friends with, or at least that's how the official story goes, to say nothing about the involvement of Swish Western. This was back when the Nerf gun handle was mostly intact, including the battery holder in the handle. I put a mosquito bat circuit in series with the stock LED sight, and guess why that was a bad idea? If you listen closely, you can hear the whine of the transformer. Of course, shorting the cap was important so it would be no danger to anyone. For some reason, I really like the organic flickering of the LED. And here's a neon bulb across the cap that turned on once a certain voltage was reached and discharged the cap somewhat. This is what this setup looked like on the inside. I think I finally found a way to prevent my rails from oxidizing. The solution involves a good dose of vinegar, obviously, and these nickel strips which I will cut in half and fold, only to realize that the strips don't touch the solution, so I'll refold them. I'm not sure how much current it will need. Maybe leave it at 10 volts and see how much current it draws. Or maybe a constant current of 100 milliamps should do it. After a while, the nickel anode starts dissolving into the solution and the nickel acetate settles at the bottom. Here's a close up of the anode, which I think looks pretty. Now for the rails. The coating is a lot better than what I expected. I think I'll leave it in here for a little while longer. That's more like it. Now I know my rails won't oxidize, so I don't have to worry about that.
8 hours later.